Welcome to the latest episode of the MFG Radio Network's Manufacturing Matters, where industry experts take deep dives into the latest technologies you need to consider to keep manufacturing moving.
I'm Elizabeth Modick, Editorial Director at GIE Media's Manufacturing Group, which is comprised of today's medical developments, aerospace manufacturing and design, and EV design and manufacturing. And we're excited to hear about the advances and challenges in additive manufacturing. This year's webinar series sponsors are ISCAR and Renishaw. ISCAR is the largest of the 15 companies comprising IMC, International Metalworking Companies, and has been a leader for nearly 70 years in the development of a dynamic and comprehensive line of innovative precision carbide metalworking tools. They have developed industry-specific solutions to optimize productivity. They understand the unique requirements of each industry and continually improve and introduce new ideas for machining intelligently. And Renishaw, a global leader in developing technology that supports manufacturing process control. Renishaw offers an advanced range of calibration, measurement, positioning, and inspection solutions. Specified by leading OEMs around the world, Renishaw encoders, calibration, and measurement systems enable superior process control down to the nanometer and picometer levels. And I would also like to thank this webinar's sponsors. First, we have Ascent Aerospace, a world-renowned single-source provider of production and automated assembly systems for the aerospace and defense industry. Ascent Aerospace produces a full suite of mold and assembly tooling required for the aerospace manufacturing market, including the largest infra molds ever made. Ascent Aerospace works with their customers to develop projects and see them through, from process engineering to build and installation, to ensure it's an efficient and cost-effective solution. Our next sponsor is Markforged, a leading additive manufacturing provider bringing industrial production to the point of need. The Digital Forge, the world's most reliable, intelligent, and easy to use additive manufacturing platform. It makes manufacturing flexible and resilient through today's ever-changing supply chains. With powerful cloud-based software, the strongest composite parts available, and the most accessible metal 3D printing, Markforged makes it simple to solve the most complex manufacturing challenges. More than 10,000 companies in 70 plus countries use Markforged to print tooling and fixtures, functional prototypes, and strong end-use production parts for specialized applications. And Xometry, your source for on-demand manufacturing with guaranteed quality, consistently low prices, and fast lead times on custom parts. Xometry creates prototypes and production parts for every industry from aerospace to medical to automotive, offering 13 plus capabilities, including CNC machining, 3D printing, sheet metal fabrication, injection molding, and urethane casting, more than 200 materials, and more than 50 finishes through our global network of more than 5,000 manufacturing facilities. Xometry works with all creators, from startups to Fortune 100 companies, and can make anything from a single prototype to millions of parts. Xometry is ITAR registered and ISO 9001 2015 and AS 9100D certified. Now, before I hand things over, let me tell you a little bit about our presenter. Terry Wohlers is founder of Wohlers Associates, which is powered by ASTM International, where he serves as head of advisory services and market intelligence. Through Wohlers Associates, Terry has provided consulting assistance to more than 280 organizations in 27 countries, as well as to nearly 200 companies in the investment community. He has authored more than 440 books, articles, and technical papers, and has given 170 keynote presentations on 6 continents. Terry served as a featured speaker in events held at the White House in 2012 and 2014, and he has appeared on many television and radio news programs. He is the principal author of the Wohlers Report, which is the undisputed industry-leading publication on additive manufacturing and 3D printing worldwide. So without further ado, let's hear from Terry.
Well, thank you, Elizabeth. Appreciate it very much for the opportunity of sharing a few thoughts over the next few minutes. And to the audience, good morning, good afternoon, or good evening, depending upon where you're located. Thank you for taking time to join us. Appreciate it very much. So with that, I'd like to begin, assuming the computer cooperates here. Here we go. So yeah, Elizabeth mentioned that we are now a part of ASTM International. We joined the organization about 15 months ago, and I couldn't be happier. The organization is world-class. The focus of Wohlers Associates has been and continues to be on consulting and advisory services, and we I've done work around the world, and we're still having a lot of fun with it. So I'm looking forward to years to come. So one thing about ASTM International, it's a standards organization, but it's really gone deep and wide into additive manufacturing, which is a little bit unusual for ASTM International because it's in so many different areas in terms of standards development. So that's one reason why we wanted to join and support what ASTM is all about. I wanted to note too that the organization is celebrating 125 years in business this year, so that's quite a milestone for the organization. The ASTM International Center of Excellence on Additive Manufacturing is housed in Washington, D.C. You can see the group of professionals there. We joined the team, so together we have about 27 people. And they're in North America, Europe, Asia, and other parts of the world. And it's just a thrill to have this much larger team so we can work on bigger projects and have more resources that we did not have before. So some of you may know about this report. Perhaps we're best known for the Wohlers Report. We've been publishing it for 27 years. The 28th annual edition will be published this year, and so you can watch for it. I'll cite some information from Wohlers Report 2022, which is the most recent edition of the report. So you can watch for some of that information in the slides that come up. So over the next about 40 minutes, we're going to talk about key advances and trends in the AM industry, obstacles to overcome to scale into production. That's what a lot of companies want to do is really, of course, they want to continue to benefit from the technology for prototyping, tooling, and so forth, but they really, the ultimate goal for not all, but many companies is really to get it into production volumes. And so a lot of work is focused in that area. And then a bit on what we can expect in the future. And so, and if you have questions about that, I'm happy to share my views. So we should have about 15 minutes at the end for Q&A. So production applications, if you look at, there's so many out there now that are emerging. The one in the upper left, of course, all of these are metal. Even the eyewear, which is TI64 titanium alloy from a company in Belgium, which was among the first really to commercialize custom fit 3D printed eyewear. And this is a beautiful frame from the company. The Chinook helicopter gearbox that you can see on the upper left, and then another part in the middle. So we're seeing many companies really push the limits to develop and bolt on these parts, aircraft, consumer products, and the like. And then large production tooling, as you see here. And this is from a company called AES. They're based in Akron, Ohio. And they're using large material extrusion systems to build these large tools. And they really are impressive when you look at what's possible with additive manufacturing. The FDA has cleared many devices for use for actually implementation into the human body. If you go back to 2012, it was in the range of 10 that were certified for use, mostly acetabular hip cups, some back spinal parts, as you see at the right, and then a host of others that have since been certified. And now it's in the range of more than 250 that have been cleared. The number in, we'll say about 10 years from then, I expect it'll be in the thousands. It's a guess. Our friends at the FDA would not say, but my guess is that it'll be in the thousands in 10 years' time. I'm sure a lot of you have heard of the Invisalign brand from Align Technology, and some of you may even have been patients, users of the plastic aligners. What I wanted to share with you is this, that if you back up 10 years, about 80,000 of these aligners, each one is unique. No two are exactly alike. You know, of course, they incrementally change your teeth because you may have 10 to 20 of these for your treatment, depending upon your case. But each of these aligners are different. That's why, you know, additive manufacturing has made it possible to do this. It wouldn't be practical to machine or somehow produce these aligners any other way. And so today, well, as of last year, late last year, about 525,000 of these are being produced every day of the week, which is, I think, is astounding, absolutely incredible. Some of the early patents from Align Technology have expired, so now we're seeing the likes of Smile Direct Club, which is a U.S. company, and then a company in Spain called Impress, which I visited last year, and both companies are doing impressive work. The automotive industry was, one of the first to really embrace additive manufacturing back in the late 80s and early 90s. But if you look at the work that's been done, it's been mostly modeling, concept modeling, prototyping, a lot of tooling, some manufacturing, but very limited. It's probably been less than 1% of 1% of all parts being produced. And even that is probably high, honestly. This is one company, a California company that's interesting, called Divergent. They have a sister company, Zinger. It's named after Kevin Zinger, who founded Divergent back in 2014. And the automobiles that he is working on, that his company is working on, are impressive, to put it mildly. The company has raised $440 million. They have 230 employees and over 500 patents. In September of last year, the company shipped a 30-kilogram aluminum chassis to Aston Martin. And so the company is now using additive to grow, to 3D print these chassis parts, which are big, which is, really at odds with additive, because it tends to work well for relatively small parts, and especially in small volumes. When you scale up, then the volumes would tend to decline, further, because, while it can be fast to produce a few parts additively, if you're producing a lot of parts, and especially big parts, it can be slower than conventional manufacturing. So what the company is doing is really first in terms of the kinds of volumes and sizes the company is producing with a metal powder bed fusion. They are working on more than 20 production platforms, and they are doing in 3 months what previously took 2.5 to 3 years to produce, right? From like a ground up platform, new chassis and so forth. And really it's impressive. These are some parts under the hood. You can recognize like the manifold and some of these intake parts, other structural parts here that were produced by additive manufacturing. They were able to reduce mass by 40% and reduce part count by 80%, which is really big. When you're talking about part count, you're really reducing part numbers and everything associated with a single part, a manufacturing process, inventory, assembly, you reduce labor, certification paperwork, and so on. And so these are some additional pictures of work by Divergent. You can see some of the optimization that has been done to the chassis and being able to produce a complete front and rear end frame and suspension, a complete redesign in three months. And then if you're familiar with brakes on cars, you can see the two different designs, the left and right here, the caliper and the upright. Really interesting work. And then we're seeing a lot of custom and limited edition products. This is one of the newer ones that I'm familiar with. These are ski goggles. I'm a snow skier. In fact, I'll be skiing later this week. And this is a product from Smith. That's a popular brand that makes helmets, other types of gear such as goggles. And you can now go online and buy this product. And so I ordered mine last week. I think it was Tuesday of last week. There's a little app that you use, a phone app, scans the face, super simple and fast. You can see a couple example scans there. And then you upload it and you put in the order. Of course, you put in some other information such as your credit card details and so forth. The price is $450. So it's not inexpensive, but a good pair of just standard goggles can cost you $200 to $300. So it's not really all that outrageous. I'm supposed to receive the goggles later this week, and so I'm looking forward to seeing how they turn out. But they are custom fit. Custom footwear. It's been around for a while. I've had the insoles on the left for I don't know. It's probably been 4 years now, in that range, 3 or 4 years. The sandals, which are also custom, for about the same amount of time, made by a company by the name of Fit My Foot, formerly named Weave. A friend founded the company and served as CEO for a number of years, and really high quality products. More recently, in fact, this past summer, I received the pair on the lower right. Those are also custom fit insoles, and those are currently, well, I have actually 3 pairs. Here's one of them. This is for show and tell. I have a pair of these, and another pair that's in a pair of shoes, and then a third that's in my ski boots. So has it maybe ski better? I don't know. Maybe not. I don't know. Maybe, but in any case, yeah. So this custom footwear is really a big thing. That and eyewear, I think, are 2 areas that will continue to see growth, and a lot of other types of products too. That, as you see here, probably the world's most expensive pen set made in titanium that you see here, platinum. Lapel pin that was made in South Africa as a gift. Other gifts that are presented to speakers at events also in South Africa. A company by the name of The Future of Jewelry, custom ring. This is in silver. This is from Gillette. In fact, I have that razor here. So what they do is they make the handle custom. So you can pick out the type of handle you want, and then also put a name or some word on it, and just put my last name on it. But yeah, so these are the kinds of products that are being produced and have been, and people will pay a premium for something that is personalized or made custom. And one thing that sets these products apart is not only are they, of course, more expensive, people will pay for it, but they won't get rid of them, at least not like they do a standard product. Like none of these products I'll get rid of. I just won't. I take a lot of them with me. I show people, I wear them, I use them, and so that really does set these products apart. I think we're going to see a whole lot more of this. Is just a small sampling of what I have in the office. I have others, but I think we'll see a lot more in the future, many more. Another example are custom guitars. One of our associate consultants, Olaf Diegel, is a great designer and is very hands-on, not only with the design tools, but also with the manufacture of the products. My newest, I have 3 of these. My newest is this one here. I don't know if he's got a name for it yet, but it's produced by the Forest system, which is now owned by Desktop Metal, and it's produced principally by binder jetting and sawdust, very fine sawdust powder, layer by layer. And in fact, over my right shoulder back there, it is sitting right there. And then I have this guy. This is the Hive over my left shoulder. And so, yeah, I've got a bit of a collection of guitars now, and they're 3D printed. Let's talk about software tools and platforms. I mean, if you look at the history of software, you needed software from the very beginning, you know, control software, you needed design software tools to produce mostly solid modeling. But since, you know, the basic solid modeling tools that came about back in the late 80s and early 90s, we've seen many other tools that you see here that help us do a better job with additive manufacturing. Some of the key companies, not all, but some of the key companies that are really at the center of the design and optimization tools are Altair, Ansys, and Topology for making analysis tools, topology optimization tools, and some other software products as well. And then, you have companies such as these who are really have focused mostly on manufacturing execution systems. And what those platforms allow you to do is really track jobs, to quote jobs, track the jobs, your capacity, your materials, customers, and so forth, even provide access to some of the information to your customers. And it's something that has been developing for many years. Materialize is one of the first with its Streamix software. It is, I guess, retiring development of it. I think it'll continue to support the software, but it now is focusing on the web-based, cloud-based CoAM, which it was Link 3D in Boulder, Colorado, that was acquired by Materialize, and now it's branded CoAM. Octane was acquired by 3D Systems, and then you have these two here as well. So keep an eye on these products. I'm sure some of you have already given them a try, and it'd be great to hear your experiences with them. But I think this is part of the evolution as you know, as the industry matures and moves into manufacturing. You need more sophisticated tools to be able to track all of your machines, the capacity, customers, and so forth. You just can't do it the old way when you had a machine here and there and a customer here and there. You really got to do it in a new way. And these tools are helping companies achieve this. Whoops. And then the big four CAD companies, Autodesk, Dassault, Siemens, and PTC, they've gotten into additive manufacturing software as well in a big way. Some of these companies have really, you know, made a large commitment, either by developing the software in-house or acquiring technology, or both. Some have done both. So a lot of activity in software tools and platforms. I want to shift to materials. If you look at, materials is everything. If you look at, you don't build parts without it. And so we have been tracking the size of the material cells for a very long time. In 2021, which is the most recent year that we have data, it's published in the Woolage Report 2022, $2.6 billion in material sales. What's interesting, at least one piece of interest here, is that photopolymers has bypassed or has surpassed photopolymers. Did I say that right? Polymer powders has surpassed photopolymers. And so if you look at the history, you can see the blue line, which is the photopolymers, has been the top selling class of material, the feedstock for additive manufacturing. In 2020, it started to shift. In fact, it was almost even, not quite. And then in 2021, you can see that the polymer powders, mostly for powder bed fusion, maybe entirely for powder bed fusion, has really gone way past photopolymers, which we thought would happen at some point because, you know, these powders are being used more for manufacturing than the photopolymers. We think, we don't have really super strong data to support that, but we have bits and pieces here that sort of suggest that powders are used more for actual part manufacturing than photopolymers. Not to discount or not to downplay the importance of photopolymers, because some of them are very, very good. I'm sitting on a bicycle saddle that is made in photopolymer by the carbon machine was used, but they're photopolymers, but Specialized is the company that manufactures it. So, you know, you can get some very good quality, and we have had for years high quality photopolymers. But thermoplastics are traditionally used more for manufacturing than thermoset materials. So this we see as an interesting trend. Shifting to industry standards, so vitally important for industries as they mature. You really have to have standards for it to mature and really have an economic impact, as one would hope and expect additive manufacturing has and will continue to have. So if you look at the number of industry standards at ASTM and ISO ASTM, because there's a partnership between the two, there were 4 standards on additive manufacturing in 2012. And if you fast forward 10 years, 39 that have been approved. If you forecast the future, we think that by 2032, about 105. And this, I wish I could take credit for this estimate, but it really comes from Pat Piccarello and his team at ASTM International. Pat is the person in charge of the ASTM Standards Committee, F42, dedicated to additive manufacturing. And so he helped with these numbers because he's very close to it. And then if you look at the standards that are in development, less than 10 back in 2012, more than 90 today. And then if you go back, if you fast forward 10 years from then, he believes that it'll be more than 100 in development at that time in 2032. So just a view of the activity. A lot of work is going on behind the scenes. And I urge you to get involved if you're not, because it's really made up of people like you and me. That I was involved for 5 years at the beginning, from 2009 to 2014. I think I have those dates. Yeah, those are the right dates. And so, yeah, I urge you, if you have an interest in helping to shape and influence industry standards that can impact your company and many others, take a look at the ASTM International F42 Committee on Additive Manufacturing Technologies. Cost is a big issue when it comes to additive, and so the cost related to support material as well. And so this is the same part, just a different view of the part. And you can see the support material. For example, this is all support material here, and these are like pins that create less contact with the actual part, making it easier to remove and finish. And the same is true here. You've got a post from the build plate on up and another one here, and support material and so forth. Now we're beginning to see companies like Velo3D, EOS, and other companies go with support-free part building, and that's an interesting trend. We'll keep an eye on it, but wouldn't it be nice to not have to take the time to build these support structures, and also referred to as anchors, because it really anchors down the features to the build plate so that the heat does not distort the features of the part. And when they do distort, it can actually move above the top layer of the build and crash into the wiper blade and then cause a system failure. And so, it's not only just distortion, but it can cause other problems as well. But wouldn't it be nice that in, a few years' time that we can build all, or at least most parts without these supports and anchors. And so, but today, this is about as good as it gets. And so you not only have to spend the time and money to build them, because some material is quite expensive, you also have to remove them. And that's what can really cost even more, is a lot of it is manual. As much as you'd like to automate this, and you can to a degree if you're doing a lot of the same part, but if you're only producing a few or one of a kind part, then typically it's too much upfront cost to automate it. So a lot of work in support material related costs. Speed is a consideration too. We want to see systems as fast as they can possibly be. For the powder bed fusion systems, both metals and polymers, but especially metals, we're seeing companies put more lasers to work. We're seeing as many as 6, 8, 10, even 12, 16 lasers working in harmony to build parts. And this, of course, can dramatically speed the process. And so we want to be able to, as I said, manufacture more parts and bigger parts, and that takes more energy, and that is one way to speed the process. And economy of scale, just maybe many of you know this already, but some of you may not. If you're relatively new to the industry, or maybe you're relatively new to powder bed fusion, both polymers and metals, you may be led to believe that you can build one part at a time, and there's really no reason to build two at a time. You just build one and then build a second one, right? Well, you can do that with material extrusion systems and maybe some of the other processes, but you tend not to do that with powder bed fusion because of the cost. You really want to pack as many parts in the build volume, at least in the XY. You may only build a certain height depending upon the parts you're building, which is fine. But you really want to pack in and optimize the build so that you can gain that economy of scale. The packing density is much less than most people think. I mean, if you look at this, it doesn't look very tight. It looks like you could get many more parts in there. But even when you get about as many as you can get, it's usually in the 8 to 12% range. It's really not. In other words, 8 to 12% of the build volume represents parts, and everything else is loose powder at the end. So yeah, you can get it up. I've seen up to 20%, but it's rare. It's really rare, and because a lot of parts are shelled, and it's just impossible to pack them too tightly, and especially in the case of metals, because you got all these support structures. And in the case of polymers, you wouldn't do this in metals, what you see here, but in polymers, you could do it, because you generally do not need support structures with polymer powder bed fusion. Will the pricing of machines, materials, and services decline? The simple answer is yes, absolutely. It will absolutely decline. It has declined some. Or in the case of machines, we've seen the same basic model. Maybe they've changed the number a little bit, but the same type of platform maybe has been the same for 20 years. The price has been the same, but what you get is a much faster, better machine, more repeatable, supports more materials, and just a better quality platform. So that price to performance ratio has improved in the case of machines. And of course, a lot of new machines that have come out also are just less expensive due to competition. And the same with materials, although my belief that they are still too expensive, generally speaking. And so, will all this decline? Yeah, through competition. We've already seen it occur, but not nearly to the degree that I would like to see it. If you would have asked me 20 years ago, would we still be paying these kinds of prices for a kilogram of material or a machine? I would say no, it'd be much less. And so, we still have room for growth and development, and it'll happen. It's just, we have to be patient. Obstacles to overcome. One is design for additive manufacturing, and you really need to design for the process, just as you would for machining or some kind of forming type process, casting, whatever it might be. You have to design for it, and that's especially true for additive manufacturing. Here's a case in point. This happens to be a guitar stand that Olaf Diegel did, and in fact, I have a version of it, but this one right here is behind me holding up the one guitar. This one is white. I just wanted to show you could fit it in your pocket, unfold it, and this is what it ends up looking like when you're done, much like what you see in the picture. But it's a great design. But the point I wanted to show you here is, of course, it is designed from what I showed, to being able to fold up and unfold and so forth. That's as part of DFAM, but this is too. Like, so what should be the gap in that hinge? If it's too tight, you can't rotate what I just rotated. If it's too loose, it'll be sloppy. So you want that gap to be just right. And through trial and error, Olaf found it's about 0.4 millimeter for a gap in this hinge. Now it's a pretty big hinge. There's a lot of surface area. So that's why it is what it is. This hinge is much smaller, and the optimum gap for it is 0.3 millimeter. And so these are the kinds of things that you tend to learn by trial and error. You don't just pick up a manual and see these things. And as much as we'd like to have access to this information, it's just not out there, at least not to the degree that we would like. And it's, of course, material and process dependent, and even dependent upon what it is you're producing, just like in the case here. So DFAM is so vitally important to producing good quality parts, and thankfully we're getting better at it. Companies are documenting and coming up with their own DFAM rules and guides within their companies, so that that it's not just simply tribal knowledge among one or two or three people, but it's documented and that can be shared with others. Part consolidation is I find it intriguing, and I'm really impressed with companies and then individuals who can consolidate as many as 855 parts into 12. I mean, that's phenomenal work, and at the same time reduce weight by 45 kilograms, as you see in this example here from GE, and at the same time improve fuel burn by 20% and increase power by 10%. I mean, it's a win. I mean, it's just and so why wouldn't you do this? Well, it takes talent to do it, and it takes it comes with a degree of risk too, because you don't know if you're going to be successful. This is another engine from GE. Used to be GE Aviation. I think they're now GE Aerospace, where they consolidated 300 parts into one. I mean, phenomenal work, absolutely impressive. And the really big win was this, though, to reduce the number of suppliers from 50 to 1. They said it was phenomenal for the company. And here's an example that we use in our DFAM courses. We've been doing the courses on design for additive manufacturing since 2015. The first two were for NASA Marshall. And this is an example that we use, where you have this aircraft seat frame. This is a small aircraft. I think it was a Beech, maybe it's Raytheon now, that 1900 C that holds, I think, 19 or so passengers. But in any case, you can see that normally it's machined out from aluminum, and there's a lot of scrap, if you can imagine, bounding box around that part. Now, if you were to optimize that with topology optimization, which is what we did, you get something that looks close to that in the middle, and then eventually to the one on the right. Through this exercise, you'll see a savings in material of about 75%, which is really, remarkable, and a weight reduction of 24%. Now, why is there such a big difference? Well, because they machined out these pockets and were able to reduce the weight quite a bit. But the big win is the material savings of nearly 75%. Now that's without a lattice structure. Now, if we introduce lattice structures with topology optimization, which we did, you can see on the right, you'll reduce the weight by an additional 56%. This is a scaled down version that we produced, and so it's in polymer. But in any case, yeah, it demonstrates what is possible with additive manufacturing and good design methodologies. Some other challenges that we see, one is the qualification and certification of parts. Well, not only parts, but the qualification of processes and materials in the case of aerospace, and then, you know, certifying parts for flight and other applications. It really, you know, it's typically not measured in weeks or months, but rather years to qualify and certify, you know, the processes, materials, and designs. And, you know, if there's a way to shorten this, we met with a company in the Middle East. This was last year, and this is one of the biggest problems is, you know, they can design, you know, they've learned how to design for additive, and they can do it in a few weeks, but then they're waiting, you know, a couple of years before they can really get the part, you know, in the air in the case of these aerospace products that they're doing. And so it's a challenge, and, you know, we're working on it, or organizations are working on it. This, by the way, is part of a certificate course that is offered by ASTM International. So you can see the other areas that are covered in the course. Talent is a challenge already, and I think it's going to be a bigger challenge in the future. You know, we have a need for people who are familiar with DFAM, for example, familiar with the AM industry and the products and services, what works, what doesn't, applications engineers, salespeople, support people, people, you know, up and down an organization, working with, you know, not only the suppliers of the products and services, but also the users of the products and services. And so, you know, if you're a young person, or a person really of any age that might be interested in, you know, a career change, or maybe you're already into the design and manufacturing and you want to, you know, move into a fast and exciting area, you know, I urge you, please, please, please consider additive manufacturing, because we need you. We absolutely do. So in summary, many interesting production applications out there. We're seeing a lot of custom and limited edition products. Cost, DFAM, and talent are among the top obstacles to growth, in my view. Those aren't all of them, but you know, we don't have time to talk about all, but those are among the top. And then prices will absolutely decrease over time. We're seeing it some. I'd like to see it happen more quickly, but the market will decide, you know, based on supply and demand and competition. The market will decide. And so it's whatever the market will bear, I guess, is what companies will charge. And if they're charging too much, they'll go out of business or make adjustments. So I'd like to finish by saying this, that, you know, we focus on consulting and advisory services. We worked on many projects, you know, hundreds of projects over the years. And, well, we've been in business now over 36 years, and, you know, contact us. We're on the web. It's easy to find us, because Google Wohlers, and, you know, send us a note, pick up the phone, contact us, and we'd be happy to chat and see if, you know, how we might be able to help you. So with that, I'd like to thank you for your attendance, and I'm happy to try to answer any questions you might have.
We've got a bunch of questions that have come in, Terry. So let's knock
Good.
some of these out. Ryan wants to know, what has Divergent figured out that the other companies have not grasped yet?
Well, Brian, that's a question that, you know, I've talked with Kevin Zinger about it a little bit, and he's presented, I guess, the meeting at America Makes. It was an annual meeting last year where he was the principal keynote speaker and gave an outstanding presentation and gave some insight, but it's still, people who I've talked with that know more about metal powder bed fusion than me, they're also puzzled. How can you do it? I'd like to see the numbers. And he has shared, honestly, quite a lot. But yeah, I honestly don't know how he's doing it, because there's a certain cost per cubic, whatever unit of measure you choose to use to produce these parts additively. And so I know that they are developing metals in-house. They're probably getting machines, maybe, well, a lot of companies get them discounted if you buy them in some quantity, but you have all the other fixed costs associated with. So Brian, I wish I knew.
They have to keep some things secret. They can only divulge so much.
Right, exactly.
Devin has asked, do you see or anticipate everyday drivers move to additive for some components?
Do I anticipate everyday drivers?
Yes.
As in driving a car?
I'm not sure now that I'm reading this. Do we see everyday drivers to move? I'm thinking more what's going to push areas for additive for some components, but maybe Devin, you can clarify for that as we move on to another question. What you were asking. Okay, let's move on to this one. Well, Devin clarifies. Chris wants to know your thoughts on ceramic AM. Is it primarily powder bed fusion with directed heat energy or more traditional 3D deposition?
Yeah, so we've seen a mix of ceramic-based systems. Some of the early work was based on the powder bed. Actually, it was a binder jetting system from then Z Corporation that evolved into Object 3D Systems, owns the technology now. Some of the later work, we're seeing even a vat photopolymerization system in Europe. One comes to mind, which is really one of the leading companies to produce ceramic parts. But we're really seeing a mix of different types of systems that are producing. In all cases, they typically undergo a furnace cycle, which then you end up with shrink in the range of 20% or even more. But yeah, we've seen a range of different processes to produce ceramic parts.
Great. And South America, excuse me, is jumping in here with a question. How can AM improve our daily lives? So far, it does not present significant advantages apart from the advance in aeronautics. I think it does with medical, as you showed and other things, but I'll let you comment on how's it improving daily lives.
Yeah, well, you're right, Elizabeth. It certainly has, and I'll come back to medical and healthcare. But I mean, what we're not seeing necessarily, I mean, I would challenge or venture to say that most technical products that we're buying today have been impacted by additive manufacturing. Maybe they weren't produced in their final form by additive, but the design and the design iteration has additive has benefited it. So some of the early concept models, the prototyping, maybe even the tooling, and so it may not be obvious to all of us, but most products today, like I say, like our computers and our handheld devices, our cars, most of the parts on cars are not most, but I don't know, it'd be hard to really guess. Maybe most parts on cars have been prototyped in that way. Probably not quarter panels, but maybe scaled, exterior parts. And then of course aerospace, and then healthcare. Yeah, when you look at dental, that's a big one. There's a lot of work that is being done in the dental area. Early on, as many as 15 years ago, doing drill guides to place implants that then secure a restoration, such as a crown or a bridge, and then crowns are also being produced in that way. and dental models, and many other the plastic aligners that I talked about, and then other healthcare products too. Well, in hearing aids too. I mean, if you were to buy a hearing aid today, a custom fit in the ear hearing aid, chances are more than 90% the most expensive and difficult part of the hearing aid is the shell, and it's made, it's a one-off, made to fit your ear, and so like I say, more than 90% chance that it'll be 3D printed. And then you look at the other parts that are acetabular hip cups. I mentioned the 250 plus parts that have been cleared by the FDA. So a lot of those products have been, ankle parts, shoulder, hip, knee, maxial and cranial facial parts. And so a lot of healthcare parts are being produced in this way. So I think it's, there more parts are being impacted, more products are being impacted than what meets the eye. It's not obvious.
Definitely. Okay, Charles, ASTM does a great job of defining standards. What is holding the industry back from adopting standards, specifically the dimensional standards in additive?
Dimensional standards?
That's what Charles says. What is holding the industry from adopting standards, specifically the dimensional standards?
Yeah, well, adoption of standards, like developing them, take a while, but then they have to sort of get out into these companies and other organizations, and that can take time. And so, I mean, if you look at, the ASTM F42 committee was formed in 2009. So it's only been around for, what is that, 10, 13, 14 years. So not that long really. And so, I think as time goes on, it'll absolutely have a bigger impact. If he could, what was his name?
I believe that was Charles that asked that.
Oh, yeah, Charles, if you could clarify what you mean by dimensional. I'm not sure exactly what that means, but I'm happy to try to provide my perspective on that. So, but yeah, I mean, it would be great if every company would adopt every, ASTM standard. It's just that, it's not practical to happen. And like I say, it takes time. So a lot of great work, a lot of very bright minds are working together to develop these standards. And the consensus standard process is sound. I mean, it's not if 51% agree on the standard and it's passed. It has to be 100% of the people voting on the standards. And like I say, it's people like you and me. If one person doesn't like the standard, it brings it to a halt, and so that has to then be addressed. And so those standards are rock solid once they become available.
Sounds good. Okay. Michael wants to know, what are some of the challenges of post-processing that you see?
Good question. Yeah, a host of challenges. One is when you finish the build, sometimes that's when the work really begins. You really have sort of three phases. One is sort of the front end, the design, and then setup, which really can be a part of that. Then the build, which is mostly automated, and in fact, entirely automated in most cases. And then the third step is the post-processing. And so that's, if it's a powder bed fusion, it's removing the powder. How do you get all the powder out of the fine channels if you have fine channels in your aerospace parts, for example? How do you remove the support structures? And you have supports in most of the processes. And so how do you do that efficiently? And then the surface finish. How do you finish the surfaces? In the case of metal parts, it often requires CNC milling, and so that requires setup. And so how do you do that efficiently? It could require coloring or some other surface treatment, other heat treatment. And so there's just a long list. I mean, if you look at a typical aerospace part, it can have as many as 10, 12, even more steps, post-processing steps to get to a finished part. And so, but the post-processing really is application dependent. the post-processing for a ring is very different than for a part that's going on to a rocket, for example, which, by the way, there's a lot of work with rockets and building combustion chambers and other parts for rockets by SpaceX and many other companies as well.
Okay, I'm digging through these questions. We've got some audiences that have a lot on their mind, and we've got about 4 more minutes. So Clemente simply wants to know the folding guitar stands. Do you know what system they were made on?
Yes, I do. It was a machine by EOS, a powder bed fusion machine, also known as laser sintering. And so it was, they were built in PA12, which is a nylon class machine material. And yeah, they come out of the machine, well, except for all the powder. When I was revolving this part right here this morning, some powder was coming. Olaf had not really finished. Well, he finished cleaning it up, but some powder was coming out. So these things are caked with powder in the holes and so forth. And he did some light weighting, as you can see on the inside here, with the pockets in that and other channels that are inside this piece here. But in any case, yeah, they're made with laser sintering, also known, which is a standard ASTM term, powder bed fusion. And so laser sintering was popularized by EOS and 3D Systems, before that DTM. And then HP, the multi-jet fusion, is a form of powder bed fusion. And so you could do similar parts with that technology from HP.
Okay, and here's a question from Bernard. He wants to know, where do you see the integration between additive and subtractive CNC machining? Do these two technologies converge, which I think they are a bit now? I'll weigh in. And if you do see it, how is it happening? Like, who's leading the effort, the additive or the CNC subtractive guys?
Yeah, good question, Bernard. And I agree, Elizabeth, they are converging, and they have on a number of fronts. One with the metal powder bed fusion, which is the popular process, most popular process for metal parts, at least for now. We're seeing a lot of those, when you're removing the support structures, then you often have to machine those surfaces, and also the surfaces which, are down welded to the build plate, which also has, some support material there too. That is removed and then typically machined off. So, excuse me, that's, CNC machining is vital, really. It's necessary. Not only that, it can be other types of material removal processes, grinding, and even hand files and so forth, depending upon what it is you're doing. With these directed energy deposition systems, really haven't talked much about them. They are taking off, and they typically can build bigger parts, often using robots to provide the motion systems. And we're seeing the integration of the additive with the milling. So they're often referred to as hybrid systems. And really the ultimate goal is to be able to have a single coordinate system, so you don't have to remove a part and index a part in a milling machine, but rather have one system and add and subtract material in an optimal way. And in an ideal world, that'll happen. Let me say that again. In the future, I think that'll happen more than it is today. Typically today, it's not automatic in the sense that the software can look at the part and then just do everything for you. You have to help the system to determine when parts should be, when it should put away the deposition head and pick up the milling head, for example, the cutter, and go to work. And so work yet needs to be done. I mean, we've made good progress with those systems, but we still have work to do to really, because of heat and distortion and so forth, you don't always, it's hard to anticipate all of that. And so you can imagine a part that distorts, and then the milling takes off when you think the part is in one place, but it's in another because of that distortion and movement that occurs. So those kinds of things are hard to anticipate, and so not all problems have been solved. But But those are two examples of how CNC milling is being used in harmony with additive manufacturing.
Terry, thank you for all of your insights. And I would quickly like to thank our sponsors. Our series sponsors, ISCAR, developers of a dynamic and comprehensive line of innovative precision carbide metalworking tools for industry-specific solutions to optimize productivity. And Renishaw, offering an advanced range of calibration, measurement, positioning, and inspection solutions, enabling superior process control down to the nanometer and picometer levels. And then today's webinar sponsors, Ascent Aerospace, a single source provider of production and automated assembly systems for the aerospace and defense industry. Mark Forged, a leading additive manufacturing provider whose digital forge makes manufacturing flexible and resilient through today's ever-changing supply chains. And Xometry, your source for on-demand manufacturing with guaranteed quality, consistently low prices, and fast lead times on custom parts for everything from every industry from aerospace to medical to automotive. So Terry, thank you so much again for your insights, and we apologize that we didn't get to all the questions that people had for you.
You're welcome. It was a pleasure. Thanks, everyone.
Everyone, have a wonderful day.
You can find more Manufacturing Matters plus the MFG Radio Network's other podcasts on Apple Music, Spotify, Google Podcast, or on our websites at todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, and evdesignandmanufacturing.com.